Good morning, everyone. Welcome to the class 847. Before starting the class, let's enjoy some movie clip related to artificial intelligence and future. Junsang, are you ready? I can't hear you yet.
예, 안녕하세요, 교수님. 혹시 들리시나요?
네, yes.
예, 제가 인공지능 관련해서 영상 하나 준비했습니다. 근데 이번에 영화 관련해서가 아니라, GPT-3의 데모가 나왔었는데,
Okay.
3의, 가 얼마나 파워풀한지 나타내는 영상 한번 틀어드리도록 하겠습니다.
네, 화면 공유해 주세요.
네.
아마 중간고사 끝나고 어느 시간, 1시간 아마 우리 학생 중에 한 명이 GPT-3에 대해서 소개하는 시간을 갖도록 하겠습니다. 예.
교수님께서 공유를 풀어주셔야지 제가 공유가 가능한 것
공유
같습니다.
중지 내리겠습니다.
혜연아, 혹시 소리 공유 어떻게 하는지 알아?
할때 소리 공유.
다음 주 월요일은 성욱이가 준비해 주세요. 하나.
알았어요.
예, 그럼 틀도록 하겠습니다.
GPT-3는 마이크로소프트가 10억 달러를 투자한 오픈 AI에서 만든 자연어 처리 인공지능 모델입니다. 6월 1일 아카이브를 통해 공개된 논문에서 GPT-3는 약 4,990억 개 데이터셋 중 가중치 샘플링을 한 3천억여 개의 데이터셋으로 사전 학습됐다고 밝혔습니다. 사람들이 GPT-3D에 놀라는 부분은 말로 단순히 설명해주는 것만으로도 실제 작동하는 앱을 코딩해낸다는 것입니다. 심지어 오류나 버그가 일어나도 GPT-3에게 설명하면 바로 디버깅이 가능했다고 디빌드의 설립자 샤리프 샤명은 말했습니다. GPT-3의 등장 이후 이를 활용한 사례들이 속속 등장했습니다. 미국의 IT 뉴스 플랫폼 해커뉴스에서는 미국 버클리대 대학생이 GPT-3로 작성한 뉴스 기사가 1위를 차지했습니다. 이 학생이 2주간 GPT-3로 생성한 기사 블로그가 1위를 차지한 후 이 블로그의 게시물들이 모두 GPT-3로 작성된 글들이라고 밝혔습니다. GPT-3에게 피그마란 디자인 툴용 코드를 학습시킨 후 말로 요구사항을 입력해서 웹사이트를 개발해낸 사례도 있습니다. 웹페이지를 만든 후 수정도 가능하다고 합니다. 텍스트 완성 및 재조합에 응용한 경우도 있는데요. 뜻이 변하지 않는 선에서 문장을 다른 단어로 재구성해주는 기능을 구현해냈다고 합니다. 문장의 앞뒤 맥락을 유추해서 빈 칸에 단어를 추천해준다고도 합니다. 또 다른 사례에서는 음식 포장지의 성분표를 사진으로 찍으면 구글에서 텍스트 추출 후 GPT-3가 성분을 확인하고 성분에 대한 설명과 건강에 좋지 않은 성분을 알려주는 기능을 구현했습니다. GPT-3가 학습한 데이터엔 한국어도 포함되어 있어서 시를 한국어로 번역시킬 수 있는데 구글의 검색에도 나오지 않는 한국적인 문구로도 해냈다고도 합니다. 그러나 GPT-3에 대한 과도한 기대를 경계하는 시각도 있습니다. 경희대 이경전 교수의 기고에 따르면 GPT-3는 n개의 단어 배열이 입력되면 n+1번째에 나올 가장 그럴듯한 단어를 출력하는 시스템입니다. GPT-3가 기존에 개발된 시스템들에 비해 낮거나 필적한 성과를 보여준 것도 사실이지만 아직은 갈 길이 멀다고 말합니다. 그 예시로 GPT-3에게 기린이 눈이 몇 개냐고 물으면 2개라는 문장을 생성합니다. 그러나 내 발은 눈이 몇 개냐고 물으면 그것도 눈이 2개라고 대답합니다. 그리고 1600년 미국 대통령은 누구냐고 물으면 엘리자베스 여왕 1세라고 대답합니다. 이렇게 아무 말 대잔치 같은 대답을 하는 이유는 GPT-3는 본질적으로 다음 단어를 차례차례 생성하는 기계이기 때문입니다. 1600년 미국 대통령 같은 단어 조합이 있는 문서에서 엘리자베스 여왕 1세가 많이 언급되었기 때문에 그런 엉뚱한 대답을 하게 된 것입니다. 마찬가지 이유로 세 자리까지 덧셈 뺄셈은 어느 정도 맞는 대답을 하지만 네 자리 이상 연산은 오류가 많습니다. 숫자의 크기가 커지면 인터넷상에 존재하는 문서에서 그 두 숫자의 연산이 나올 확률이 적기 때문입니다. 포브스지 AI 컬럼니스트인 로프토우는 기고를 통해 GPT-3에 대한 광범위한 오해와 과장이 있다. 추론 능력이 떨어지는 GPT-3가 할 수 있는 것과 할 수 없는 것을 구분할 필요가 있다라고 얘기했습니다. 그럼에도 불구하고 GPT-3가 보여준 뛰어난 성능은 많은 변화를 가져올 수 있습니다. 마이크로소프트에서는 오픈 AI와 GPT-3에 대한 독점 계약을 체결했습니다. 기본 코드를 열람하고 변경할 수 있는 계약입니다. 이에 대해 일론 머스크 테슬라 CEO는 공개적으로 비난했습니다. 일론 머스크는 마이크로소프트와 계약한 오픈 AI를 향해 기업의 이름인 오픈과는 반대되는 행태라며 이제 오픈 AI는 마이크로소프트가 독차지한 꼴이라고 트위터에 남겼습니다. 재밌는 건 오픈 AI는 2015년 일론 머스크의 도움으로 설립된 기업이기도 합니다. 다음에도 흥미로운 이야기로 찾아오겠습니다. 다큐를
네, 고맙습니다. 재미있게 잘 봤습니다. 이 GPT-3도 중요한 것 중에 하나가 이제 트랜스포머 러닝이라는 기법이 들어가고 어텐션이라는 네트워크가 들어가서 이렇게 강력해진 건데 결국은 뉴럴 네트워크가 복잡해지고 백 프로퍼게이션 여기도 똑같이 있어요. 학습하는 우리가 수업에서 하는 원리하고 다 똑같고요. 복잡도가 높다는 것 뿐이고 그러니까 많은 인력과 자본이 투입이 되는 거고 그 다음에 컴퓨터가 강력하고 복잡할수록 그렇습니다. 자, 그래서 아마 우리가 중간고사 이후로 한번 다시 이 주제에 대해서 아마 우리 학생 중에 한 명 공부한 학생이 있는데 한번 여러분께 발표드리도록 하겠습니다. 일단 지금 우리 DNN의 기본인 그 연결, forward propagation, backward propagation, gradient descent는 그대로 원리는 똑같다는 말씀을 다시 한번 강조드리고 그러기 때문에 이 수업을 지금 하고 있는 겁니다. 성욱이가 다음 주 월요일에 한번 준비해 보실래요? 네, 가능하면 영어 클립으로 하면은 더 수업에 맞을 것 같고 약간 영화 계통으로 이렇게 한번 가보도록 하죠. 네, 왜냐면 저 아까 틀어준 유튜브는 이제 그분의 허락을 안 받은 것도 있고 해서. Okay, let's start the class right now. Let me share the Okay, let's start the class again. Last Monday in the class, I was driving some equation for backward propagation. Especially, it was the chain rule. We developed the chain rule equations. For the simplicity of derivation, I used a case where we have only one input layer and one output layer and one hidden layer. This is the case of three-layer case. As I mentioned many times, a generalization to 100 or 1,000 layers are very straightforward. The principles are same. And also, we have connection W1 and W2. The training of the neural network means optimization of W1 and W2. We believe 화면 공유 더 많이 익숙해졌죠. Thank you. 성욱, can you hear me? Thank you. I love you too. Okay. So let's review the previous class again. The backpropagation is very important part of the principle of deep neural network. For the simplicity of analysis, I was considering a case where we have a one input layer and one output layer and one hidden layer. Generalization of this chain rule up to 100 layers or thousands layers are very straightforward. So principle will be the same. We have a weight W1 and W2. DNN training means optimization of W2. The purpose in general case of machine learning, or for the purpose of optimization, we are using gradient descent method. Now for the simplicity of analysis, we assume that X is a scalar, H is scalar, and Y is scalar. Actual case, it is very big size vectors. So we spend some time to derive these equations. This is update equation to go up to optimal point. This relation is the gradient descent method. So we was able to derive this equation, gradient of this cost function. In this case, cost function was mean square error and activation function was sigmoid. This makes very simple mathematics, and we was able to derive this equation. In this case, delta y is the some key element, and also we was able to derive the update equation for W1. Here also we have delta H. Delta Y was defined by this equation. Y was the output of the output, and Y dash is the target value. Y 1 minus Y actually coming from derivative of sigmoid function. And if we have delta Y, actually also we can derive the equation for delta H. So with the given delta Y is given this equation, we can derive equation to update W2. With the delta Y and the W2, we can derive the equation for delta H. With the delta H given, we can also update W1. So that's why we call chain rule. This propagation, backpropagation principle is not just limited to DNN. And next week, probably we are going to talk about RNN, and also beginning of April, we will talk about CNN. Probably GPT-3 or AlphaGo, they all are using the same principle. So even though this is very simple mathematical distribution, this is really solid background for very, very complex machine learning. And later on, after midterm exam, I'm gonna combine this machine learning with reinforcement learning. That is called deep reinforcement learning. That is really advanced deep learning algorithm, but still, I would say that these backpropagation principles are the same. Now, I would like to move on to cost function. In the previous derivation, I used mean square function. Mean square error function is y minus y dash square. Very easy to understand. The difference of our output and target value and square. So this optimization will continue up to where y is equal to y dash. So it is very simple and useful, but sometimes it is not good enough. Sometimes because of this derivative, let's assume that y is near 1, then it has become very small number. Or when y is near 0, delta y is very small number. That means this gradient is very small number. That means that it will be very slow training process. Optimization will take a lot of time. So there are some disadvantages of mean square cost function. Because of that, today I'm going to talk about the new cost function that is called entropy. Entropy is not easy to understand, but I will spend an hour to talk about entropy cost function. In a case of CNN and RNN, some advanced deep neural network, they are using entropy cost function. So I will spend time today to talk about entropy cost function. As I said that cost function so up to so far we have used this cost function, but the disadvantage is that training process is very slow. Why the cost function is important? Because probably next Monday, I'm going to talk about the regressions. Sometimes, depending on the purpose of deep neural network, sometimes it is suitable for classification purpose. Sometimes it may be suitable for linear regression purpose. So depending on the applications, we have to use different type of cost function. Also, it will determine training efficiency. Sometimes it is slow optimization process. Sometimes it will give very slow or fast, depending on different type of the cost function. And it also depends on models. So it will affect also training efficiency, and also the selection of cost function will depend on models and your previous experiences. Now I would like to talk about different type of cost function that is called cross entropy. The equation looks like this. In the previous case, we used this mean square cost function, but now I'd like to talk about the cross function that is written by this equation. Here again, this y dash is target output, and y is output. And also we assume that y is from 0 to 1. And I think this is a very useful cost function, and I would like to talk about that today. There are two parts in this cost cross entropy. This will be the part 1, and this part will be part 2. This term becomes dominant when y is near the 0. As I said that there are some, the output, this is more suitable for classification, where output is from 0 to 1. Actually, y means probability. Let's assume that you have an AlphaGo machine learning algorithm. You have a black stone here, white stone here is a black stone here. Where will be the next spot to win this game? And so each potential spot will have different probabilities. Probably we will choose a point where it has the highest value, probably y is near 1. Somewhere this point is y is near 0. And this point maybe some place will be y dash is near 1, and some place y dash is near 0. So there are some expected value, that is the target output, and actually our output. There might be some differences between your target value and your deep neural network output value. You can obtain this target value from previous record of Go games, which will be available from the internet, or sometimes you have previous AlphaGo model 1 and AlphaGo model 2. They can play a Go game. Those records will give us this y dash. And it is a probabilities. If y dash is 0 near, it means that AlphaGo is recommend you not to put your stone on here. If y dash is near 1, that means that AlphaGo is recommending you to put your stone on here. So, but your deep neural network may output a certain point is near 1, certain point near 0. So there might be discrepancies between your machine learning output and your target value. So anyhow, this part 1 is dominant when your output is near 0. So your cost function will be more dominant or by this first part when you have output y is near 1. On the other hand, this part 2 is more dominant when y is near equal to 1. You see that if 1 minus y is very small number, minus log means this is infinite number. So that is a very short summary of, so when you are optimizing W1 and W2, W1 and W2, we had certain chain rules. Those are, I mean, here we have this kind of terms and y minus y terms. Those are coming from the properties of cost function and the activation function. Here in this case, if we use the cost function, use this cross entropy, and the optimization speed will be much faster, but by this term, if your output is near 0, and if your output is near 1, this slope gradient, this c will be very large number, very fast when your output y is equal to 1. On the other hand, if you are using mean square errors, there is no logarithm here. So it is a kind of linear term, y minus y dash. So if the difference is very small number, this delta y is becoming very small, that means your training process will be very slow. But small difference, small number near zero, log small number is really very large number. That is the property of logarithm. So then in this case, C is very large number, and also gradient will be very large. So at the edge near 0 or near 1, gradient will be very fast and training process will be very fast. That is the basic property of cross entropy. Now let's move on to next page to go a little bit deeper. There is the definition of cross entropy cost function. Now you see that, as I mentioned, that this term is very dominant when y is near 0. You see that log y function has this form. It has minus infinite near 0. In your high school or engineering first year, you may have had a chance to learn about the logarithm of function properties. Anyhow, let's take a look at the property of y. When y is infinite, of course, log y is infinite. And because of log property, it is a little bit slowed down compared to exponential function or linear function. But anyhow, as I mentioned before, y is from this area. Y is from 0 to 1. Probability cannot exceed 1. And if y is becoming very near 0, like 0.00001, then it will go to minus infinite. But however, in our cost function of a cross entropy, we have minus sign here. That means the log y will be flipped, and this will be minus log y graph. So now this is actually a cost function of this part. It will go very, very fast. Here means that if your output is near zero, then the slope will be very fast. Gradient will be very fast. And it will, if we keep on updating your weight using this cost function, it will go to this optimal point as fast as possible. Cost is 0. This is the point where cost is 0, when means W becomes optimal number. So as I show you before, we will do a lot of, let's assume this is cost function. Initially, we may be here, keep going on, and we will reach certain point. Initially, we will start here, and we will keep on the back propagation, and finally, we hope to come back to this point. This point is actually, what does that mean? Eventually, it will reach a point somewhere cost is becoming to 0. That is why we choose this cross entropy cost function. So this term is suitable when this is the suitable cost function when y dash equal to 1. Let's talk about this. So let's assume that you have output vector this is let's assume this is target number and this is what you are trying to do. So let's assume that your actually answer is this one, once a certain jth column. Let's assume this is tiger. Let's assume that you show the picture of in your neural network and the answer should be tiger. That means jth column is tiger and the correct answer is the number 1 here. But let's assume that during the training process, you have this is cat and this is cow, and let's assume this is tiger. So still y is not y dash yet. So if you apply this cost function at this jth column, and then this term is becoming 1, then this term is becoming 2, 0. So dominant cost function will be this one at this column. Probably in this point, this the second part will be dominant cost function. I think the efficiency of my class may not be good at this moment because of my poor English. But even though I am a native English speaker, this explanation is not easy. But be patient. This is the beauty of cross entropy cost function and beauty of mathematics and beauty of a deep neural network. That's why I'm saying that in order to be a good machine learning engineers, you should have very good mathematical background, because if you want to develop a new model like GPT-3, or in the future you can develop your own model, mathematical background is very, very important. Because if you have very good mathematical background, depending on your models, you can develop your own cost functions and activation functions. And also there are many matrix and tensor operations. If you have good ideas on a concept on those, you will be more confident on developing on the model. Second capability you may have to do is you should be able to understand software coding, Python and C or MATLAB, because you have to demonstrate that. Third capability is that generation of data you can obtain from the internet or you can obtain from computer simulations. Also, you have to be able to understand the computer architecture itself. Last one is that you have to be able to apply your model to certain applications. So you should have domain knowledges. So it will take some time to be able to be really a machine learning expert. But first step to be a good AI expert, machine learning expert, is the mathematics. And that's, I keep telling you that. And in this class, I'm just using a lot of equations. Yes, maybe during your midterm and final exam, you will have some chance to do your own coding and demonstrations. But at this, at the start in this class, I will spend more time on that, on the mathematics. Now let's come back. Let's assume you have machine learning and you show a picture. You have to classify whether it is tiger or cat or cat or tiger. And let's assume that in this picture, we will do the forward propagation and backward propagation. In the backward propagation, we need this cost function and gradient descent. Let's assume that your target answer, labeled answers of jth column is 1. That means this picture is tiger. You have jth column output, that should be 1. So in the cost function is the sum of all these parts. Cost function is all this part, and the cost function will be defined by the difference and cross entropy of the C over case 1, 2, 3, 4, 4 to up to 100. So total cost function will be summation of each column's cost function. Let's take a look at this J's column case where J's column output is equal to 1. That means this term is become to 0. Because y dash is equal to 1. That means on the remaining part of the cost function is the first part of the this cross entropy cost function. So then it becomes C equal to minus log y. Actually, J becomes minus log y. And accordingly, this is become to this one. So this is actually becoming the cost function. You see that y, J's column of y is now 0.9, somewhere here. It has to go faster and fast, and gradually 0.9, it will start from 9, 0.1, 0.2, 0.3, and now it's near 0.9. Eventually, y has to go to 0.1. So it is in the mean square error cost function is a kind of parabolic, very slow. But here it is a logarithmic function, and derivative of this logarithm function is really high number. So initially it will go very fast training, and eventually it will reach 0.1. That is the target value of y. Junsang, thank you for showing your face in the Zoom. It's a little bit difficult, but can you follow up a little bit? Would you tell us something about this, your opinion?
지금 사실
Okay.
코스트 펑션의 최저값을 이제 찾기 위해서 그레디언트 디센트를 이용해서 이제 찾아가는 과정인데, 거기서 이제 그레디언트 디센트를 이용해서 이 코스트 펑션의 이제 최저값을 찾아가는데, 거기서 이제 이 확률 분포에 따라 이제 코스트 펑션의 이제 최저값이 결정되는 좀 그런 상황이라는 거는 이제 이해가 되는데, 이제
특히
따로 보고 있습니다.
특히 이 부분 초기에 빨리빨리 학습을 찾아가야 되는데 이분이 느린데 여기에 코스트 로그 함수를 씌우면 굉장히 빨라진다. 이게 핵심이고요. 이게 두 개의 파트가 있는데 투 파트가 있는데 요 파트는 이런 정답인 사이트를 빨리 학습시키고 요 두 번째 파트는 정답이 아닌 0에 가까운 거를 빨리 학습시키는 용도로 두 개가 사용된다. 이게 되겠습니다.
Yes, Professor. I'm sorry that I forgot to use English. Okay.
Yeah, thank you. So, so as I show you many times, sigmoid function is a combination of exponential function. It is very smooth function and differentiable. But sometimes sigmoid function, because of the exponential property, especially exponential minus x, it will have some slow derivatives at certain point. When y is near 1 or y is near 0. To compensate that, a slow training process, slow derivatives, and slow gradient, we are using this logarithm. That is called cross entropy. Now let's move on. Once again, Now I would like to talk about this part 2. As I mentioned in the previous slide, this first part of this cross entropy function is dominant and very helpful to update weight W when for the case where it has the target value 1. But there are other terms we also should define the cost function of other part. And when we define the total cost function, we have to add all these cost functions. So purpose of this gradient, this means that this column should reach as fast as possible to 1. The other element should be 0, trained to be 0 as fast as possible. This second part is more responsible for this part. Because of minus, actually this was, and now we have new term here. Because 1 minus, this graph will be flipped, mirror image, and then 1 minus means reference to 0. This y will be flipped, and that is log minus y, and because of 1, it will move up to here. So that's why this curve is actually I would say this might be minus log minus y. Log y, this y, okay. This log minus y, and 1 minus means the shift by 1. So actually this is becoming the second part of this cost error function. And this second part is dominant when y dash is equal to 0. That is the case where this kind of term, this cat cow, the right answer is a tiger, but cat cow, the number should be near 0, and that is the case. But if y dash is equal to 0, this term will dissipate. So only the remaining dominant part will be like that. So this will be the answer point. Y dash is equal to 0. So initially, training process will start here. So when y is near 1, the slope gradient of y cost function will be really infinite. So it will start very fast training process, and it eventually reach it to a point y is equal to 0. That is a case where cost function is becoming to 0. That is the optimal point of W opt. So today I'm spending a lot of time to talk about the meaning of this cross entropy function. The main message today is that there will be many different types of cost function. It could be linear, square, mean square error, logarithmic exponential, or softmax. And probably sometime next week, I'm going to talk about softmax function as well. There could be maybe hundreds of different types. Probably in the library, TensorFlow or some libraries, you may be able to choose different type of cost function. But I would say there might be 100 design elements when you are developing new models for your machine learning. And I think one of the important design parameters is choosing the right cost function. Depending on what type of cost function you are going to use, the speed of your training will be very different. Also, the accuracy, a certain iteration of training process, you have to compare with the different models. Accuracy might be different depending on the choice of your cost function. In this class, I'm going to only talk about two different. First one is mean square, and second one is the this cross entropy. But also there are some beauty of cross entropy. That's why I'm spending time today class to talk about cross entropy function. It is more suitable. This cost function is more suitable for classification purpose. My main message is that there will be many different type of cost functions. It is your responsibilities and opportunities to choose right cost function. Then your model will be much efficient. Now let's talk a little bit about gradient. Why we are talking about gradient? Because during the back propagation, we need to be able to obtain equation of derivative of cost function with respect to W. With given this derivative, we was able to update W using this gradient descent equation. And alpha is the ratio, learning ratio. And if you should be able to, if you have a gradient of cost function with respect to W, you can obtain this iteration equation. Now you can compete this equation for W1 and W2 and W100, and during these derivations, you should derive the chain rule. For the simple case, we derived this chain rule in the previous class and at the beginning of this class. And this is for the only case delta y and delta h. We can define delta 1, delta 2, delta up to delta 100. If you develop this chain rule, that means you develop a new machine learning model. So even though we are using libraries for the easy process of work, but if you are really machine learning scientist, you should develop a new machine learning model. Then in those cases, you should determine the cost function and activation function, and also you should derive all these chain rule equations. So what does that mean is that we should be, in order to this work, for the case of cross entropy function in your deep neural network model, we have to derive the derivative of cross entropy function. I will do that. You know that let me start this differentiation process. Now, let's discuss about this gradient of cross entropy cost functions. Here, I assume that activation function is sigmoid and cost function is cross entropy. As I mentioned before, in order to execute back propagation, we have to derive the equation for derivative of cost function with respect to weight. And then we can update W vectors and matrix and to make the machine learning more smarter and smarter. And now let's do the derivative of cost function. Derivative of cost function is actually coming up here, 1 minus y. And here also derivative of log function 1 minus y actually coming to 1 minus y. Because of what minus sign here, we will have minus here. In this time, y dash is actually constant. And then we have to have a derivative term of y respect to w. Because y is sigmoid function, we know that if derivative of y will have x plus y 1 minus y, and then y will be cancelled each other to come to this equation, and this part will come to here because 1 minus 1 y and 1 minus y will cancel each other, and eventually we will obtain this derivative function. Now, important property of this gradient is that derivative of c is really proportional to y minus y dash. What does that mean is that if output difference between your output and your target number is large, then derivative will be large. That means you will have very fast gradient. That means that you will have very fast learning process. That's why we observed here near this point, when target value is here and your output is here, that there are big difference, then slope will be much larger. Then it will go very fast. That is very important part of cross entropy cost function. Meanwhile, let's take a look at of the previous class, summary of previous class. It may not be here. Okay. The delta y, actually that is related to the slope of this training process. It has y 1 minus y term. Y 1 minus y. That means when y is near 0, delta y is becoming 0. Near 0, it has to have very large slope and it has to have very large gradient. But on the other hand, if you use mean square error, when y is near 1 equal or to 0 or y is near equal to 1, actually this term is becoming to 0. Delta y is becoming 0. So it is very slow learning process near delta near y is near 0 or y is near 1. On the other hand, if you choose cross entropy function, surprisingly, at this your gradient is proportional to difference. If the difference is large, it will have very large gradient, and that means that your optimization will be fast. That is the beauty of this cross entropy function. Joungho, can you follow us this mathematics? 네, 좋습니다. 근데 그 컴퓨터에 마이크인가 뭐 인터넷이 좀 불량한 것 같아. 음성 변조 같았어. Okay. So today I'm focusing more on the cost function. One of the powerful cost function is cross entropy function, and I'm talking about the property of this cross entropy function. Now, I would like to give you some numerical example. Now, I assume that a cost function is let's talk about case A where y dash is equal to 1. Let's assume that target value is 1. That is the right answer. And right now, I assume that y is equal to 0.98. So this is a case where we are very close to here, very close to the right number. And then cost function A will be so in this case, on this example, we just apply these numbers to calculate the cost, entropy cost. The number is now 0.0291. So what I would say, let's take a look at this. In order to give you more idea about cross entropy function, I will do some numerical calculations. Let's assume that I'm using this cross entropy function for your cost function, and let's compare two different cases where y dash is equal to 1. That means target number is 1 and your output is 0.09. I think that is the case where I think this case. Now your case A is a 0.98 and this point is y dash is equal to 1. Now in those cases, what I found is that slope, this cost function is actually cost function difference is 0.0291. But however, in this case, your output is here, 0.001. The target value is here. So there are so much difference. And also cost function here is 13.2877. What I mean is that if your target value and your output value has large size, cost function is large. And also slope is very large because slope is proportional to difference between your target value and your output value. So slope is very large. But however, when your output is near a target value here, the cost function is very small. And because of cost function is very small, derivative is very small. So if you choose this cross entropy function for your cost function, it has very good property. So that is the beauty of the cross entropy function. Now, next Monday, I will continue this class about the cross entropy function. And also I'm gonna talk about a little bit different activation function called softmax function. And also this optimization process of backpropagation can be explained using regression. That is statistical method. I'm going to keep going on this mathematical background next Monday and next Tuesday. Thank you for your kind attention. And I would like to say again, this is beauty of mathematics because you have to be able to have good mathematical background, because if you want to be a designer of new machine learning model, you should choose your cost function and activation function. And so some people say that, oh, cross-entry function is very suitable for your applications. But in order to understand or discuss with him, you should have able to have understanding the basic property of these functions. And one of them is cross-entropy functions. Thank you for your kind attention.